Hi guys, my name is Trevor Sullivan and welcome to another CBT Nuggets skill. In this skill, we are going to be talking about the etcd key value store. Now, etcd is the default key value store that is used to back a Kubernetes cluster. So when you provision different resources into your Kubernetes cluster, the etcd key value store is where it's going to place all of the different resource configurations and track and monitor the state of those different resources within your Kubernetes cluster. When you use the kubeadm utility to build your own cluster, it will install etcd for you on a single node cluster. And then when you add additional worker nodes, and actually if you add additional cluster nodes, the actual master nodes that are running the kind of back end of the cluster, then it's going to create additional instances of this etcd key value store for you so that you have high availability of that etcd key value store across the different nodes in the cluster. Now, when you use kubeadm to initialize the cluster, that's kind of doing your entire process end to end, where you're starting from basically nothing, and then at the end of running kubeadm, you actually have an up and running Kubernetes cluster. However, we can actually separate out just the etcd component and run it in its own dedicated cluster instead. So in this particular example, what you can see here is that we are running basically 3 different Linux virtual machines, and this could be running on, on premises, for example. It could be running in your cloud provider of choice. It doesn't really matter where exactly you are running these virtual machines, because we're actually going to be using kubeadm to provision all of the etcd instances locally. So you don't need to worry about relying on any cloud providers, different types of resources, load balancers and things like that. We're just going to focus on how to create this etcd cluster locally. Now, kubeadm actually allows us to kind of bypass the setup process for Kubernetes master nodes, and instead we can just run the initialization phase for etcd itself. And so what we can end up with as a result is we'll basically have the etcd component installed onto our Linux virtual machines here. However, we're not going to have any of the Kubernetes master resources running on these servers. Now, this does require that you still have to, of course, install kubeadm itself. You also have to make sure that you install the kubelet component as well. So you are still installing some of the kind of prerequisites that you are accustomed to if you have gone through my other training on how to set up a cluster with kubeadm. However, what you're not doing is you're not actually setting up the worker node components themselves. You're just kind of creating your etcd cluster as a separate cluster of systems. Now, why would you want to do this at all? Well, the reason here is that you can actually set up etcd as its own dedicated service running on several different cluster nodes here. And then later on, once you're actually ready to provision your Kubernetes cluster, you can provision additional virtual machines and then use those as your master nodes in your cluster. And then you can basically take all of these master nodes and you can just point them over to your etcd cluster over here. And that will allow you to ensure that the etcd component itself is highly available. And then separately, you can ensure that your Kubernetes master nodes are highly available as well. And this gives you what's known commonly as separation of concern, where I've got my etcd nodes running over here, and that's kind of managed as its own standalone service. There's no implications that I'm necessarily running Kubernetes here. However, over here, when I actually do go to deploy my Kubernetes cluster, I can simply remove etcd from all of these master nodes. So I don't need to run etcd locally on all of the individual master nodes here. And instead, I can just point all of those master nodes over to my etcd cluster. Now, in order to accomplish something like this, you would, of course, have to put a load balancer in between the master nodes here and all of your etcd worker nodes. But for the time being, we are just going to kind of skip over setting up Kubernetes in this particular configuration And instead, we're going to be focusing on the etcd key value store itself and how to actually initialize a cluster like this. Now, I'm going to be doing a demonstration of this on Amazon Web Services, but of course, you could run these virtual machines on your local network if you wanted to. If you're using Microsoft Azure or Google Cloud or Linode or DigitalOcean or any of the other cloud vendors out there, you'll be able to kind of replicate this because these are just virtual machines that are all running on a shared network, and they just need to be able to communicate with each other over a couple of TCP ports, TCP 2379 and TCP 2380. So as long as you have those ports open between all of the nodes in the cluster, you'll be able to successfully set up this cluster. Of course, you also need to have inbound SSH access allowed so that we can actually log in to these virtual machines and install all of the necessary components. Now, the Kubernetes project itself actually has some excellent documentation on how to set up this configuration. And if you head out to kubernetes.io and you look for a document called Setup High Availability etcd Cluster with kubeadm, that is what we are going to be kind of following as a guide and tutorial in order to set up this configuration. So aside from, inbound SSH access and making sure TCP 2379 and 2380 are open in between the nodes, that's pretty much all we need from a core infrastructure perspective. So we're going to start out by just setting up a few virtual machines, make sure they're all on the same network locally, and make sure that our security group or firewall rules are allowing that TCP network traffic. But then after that, the steps are all kind of documented pretty well for us here in terms of what we need to actually install onto our cluster. Now, before we actually get into the installation of the cluster itself, one of the prerequisites that you're going to see in the documentation here is that each host in the cluster needs to have a container runtime, the kubelet, and kubeadm installed. And when you need to install those components, you can actually just head over to the guide for installing kubeadm. And this is going to kind of guide you through the individual setup steps in order to get kubeadm installed, as well as the kubelet. Now, one thing that they'll kind of take you through here in this document that we don't need to worry about is installing kubectl. And we don't need kubectl because we're not actually setting up a Kubernetes cluster in this particular case. We're just installing the kubelet component and then the kubeadm utility that's used to administer Kubernetes clusters, but we're not even using kubeadm to set up a cluster. I know that can sound a little bit confusing if you're new to Kubernetes and just new to this whole ecosystem of tools, but kubeadm does have functionality in it that allows you to set up your etcd cluster without actually setting up a Kubernetes master node or multiple Kubernetes master nodes. So we're going to follow this guide to get kubeadm and kubelet installed, and then we'll come back to this guide for setting up the high availability cluster with etcd, and then we'll kind of start to run through the individual setup steps to install the necessary components onto the cluster. And then at the very end, we'll actually validate our configuration and ensure that the etcd service is accessible on all three of the nodes within the cluster. And we can do that by actually using a container image for etcd. So if we drill down here into the check cluster health step right down here, which they say is optional, but I think that's kind of imperative because you need to make sure that your cluster is actually healthy before you kind of proceed and start doing other things with the cluster, like adding keys and values into it and perhaps connecting a Kubernetes cluster over into that etcd cluster. There's always just the necessity of monitoring that cluster's health to make sure that it's healthy on its initial setup, as well as healthy on an ongoing basis to ensure that whatever applications are hitting this etcd cluster are going to be able to access it. And if it were to go down for any reason, you do of course want to get some kind of automated notification about it. But that's kind of beyond the scope of this. But what we can do here is there's a Docker command that we can use in order to grab an etcd container image from the Google Cloud Registry or Google Container Registry, GCR. And we're just going to basically launch the etcd ctl command line utility, which is the utility that you typically use to interact with a cluster. That allows you to administer the cluster. You can check the cluster's health using the endpoint health command. And you can also do things like set values and retrieve values from the cluster using the same utility as well. So there's a whole bunch of functionality that this utility offers. Also things like backing up and restoring your etcd cluster if you want to make a backup copy of it and then maybe ship it to a different environment and then restore that backup onto a different etcd cluster overall, then you can do that with this utility as well. So that's going to be a really essential tool to understand as you are administering etcd as well as Kubernetes clusters that are dependent on etcd, whether it's a standalone etcd instance or you're running etcd locally on each Kubernetes master node, or in this case where we are running etcd as its own separate cluster of services. So let's go ahead and jump into the next video where we will actually start out by setting up a few virtual machines here in the cloud so that we can start to set up our etcd cluster onto these nodes. I hope this has been informative for you, and I'd like to thank you for viewing.